Welcome back to my game dev stream. So in this video I wanted to carry on with the battle stuff, the battle sequence, I suppose. So I'll show you where it's at right now and then we'll go over the code a little bit. So I jump into here, I cranked up the battle to a 1 second delay in between battles. Now I changed it as well so if you keep pushing down, it'll just cycle through. Same with if you keep pushing up. So if I select an attack, it'll do an amount of damage to the enemy. He'll do some damage to me if I'm still alive. And it will keep cycling through this until one of us dies. So I killed him, and then I'll go back into this screen and it set it back to a 1 second in between battles. And I'll keep going here. So obviously with 25 damage done in each attack, just hard-coded in, he of course killed me there, and then the game died, or ended I should say. So I don't have a death screen right now, but I'll put one back in at some point. Now the way that I'm handling all that is I have a section here with some battle state Boolean values. So show intro, show attacks, that's the attack menu. Show damage to enemy, that of course tells you how much you've done to the enemy. Same with damage to player. And then show enemy death, that of course will show the you killed the enemy dialogue there. I'm also saving damage to enemy and damage to player as floats, and we can use those to display them and to do the actual calculations for decrementing the player and enemy health. So going down here into our handle key down function, that's mainly what's changing all of that state. Because obviously we're in a loop, and that loop keeps occurring until the enemy is dead, or until the player dies, as the case may be. So if we're in that loop, we're showing the intro screen first, and if you hit space key, if we're still showing the intro screen, we set that to false, and then we want to show the attacks. So it will of course keep showing those until you hit space again, at which point we calculate how much damage we do to the enemy, and that calls out to this calculate damage function. Within there, we pass in the attacker and the defender. So in this case, our attacker is you, the player, and our defender is the enemy. Right now I have that hard-coded to 25 hit points. So if we go back down here, we adjust the enemy's health based on that amount of damage. Then we show that damage to enemy screen. And when that is showing, we expect the spacebar to be pressed again, because that's basically the action key. And then we do the same kind of thing for doing damage to the player, but first we check to see if the enemy is actually dead. And if that's the case, then we just want to show the enemy death screen. Otherwise, we take damage ourselves as the player. And again, here we show the damage to player screen. So let me just run through that. So this is the intro screen. Let me move this over a bit. So showing intro would be true right now. If we press the space bar, that goes down into this condition, showing the attacks. And if I press space again, that of course calculates the damage and does the damage to the enemy, which of course you can see their health went down. And then we set this show damage to enemy screen, which it is showing here, 25 damage to enemy. If we hit space again, that of course shows damage to player. You took 25 damage and our health went down. So if we keep going through that cycle, here is that final show enemy death. You've killed the enemy. So it's pretty simple there. It's basically just a simplistic state machine, I guess you could say. I don't know if it technically is or not a state machine in the computer science sense, but I'm going to call it that anyway. Ultimately, down in our render function, we're just showing the specific screen or specific state based on those booleans, and those go in sequential order. So only one of those booleans is going to be set to true at any given time, and after we render whatever is inside that condition, we just return out of this, so we don't have to check more conditions each time. Now, one thing that I'd like to do here, or start to do anyway, is look at this calculate damage function. And to begin not hard coding that, I guess we need to take a step even farther back and look at our generate enemy function, because right now that stuff is getting hard coded and I don't want to do that. I want to I guess randomly generate some of these within certain parameters. So I'm doing that a little bit here in my HTML JavaScript rendition of this. So the defense, it's essentially going to be generating a number between randomly between 1 and 6, and then we're adding 10 to that. So it's, I guess, essentially saying that the defense that gets generated will be between 10 and, well, I guess 11 and 16 or 17. The random number generation in JavaScript is a little bit janky, so we'll just assume that we want our enemy's defense to be between 10 and, say, 15, I think, just to start out. So we do have a random number generation function here in a utility namespace. So we'll just look at using that here. I don't know why I did a plus 10 on that. I mean, I could just generate between, say, 10 and 15. So why don't we do that? So defense is going to be util, what do I call that? Random int. Random int, so 10, 15. Sorry, I kind of wanted to... I wish it would show me that type when I'm introspecting here, but I'll just have to go to that. So for stats, yeah, we have defense, speed, and luck as integers, so that works to use the random int function. Let's see. We did the same thing for speed. Let's put that in. I don't have luck really built. Oh yeah, I do. Between 1 and 35. So let's do that. And then, what is this? Bring me back to my command line. What on earth is going on here? Okay, here we are. So let's build and just see what that gives us in game. So we have defense is 12, speed is 12, and luck is 24. Kill this guy quick. We'll see who comes up next. So 15, 15, 17. Do this again. I'd like to see a case where those are not the same. 15, 15, 27. 11, 11, 27. Why am I getting the same thing? That's strange. Random, so it's based on a timestamp. So I guess this is pseudo-random. What happens if I change this to like a 16? Are we still going to get the same number? Is that going to be basing it on essentially the same timestamp? (10, 16, 28). That's not bad. 12, 14, 28. I can take that. So if I have those the same, oops, I gotta recompile that. That is interesting behavior. There's something to note for the future. Yeah, 12, 12, 32, 11, 11, 29. That's a little bit unnerving, to be honest with you. What if I do... say 0 to 7 plus 0 to 7. Am I still going to get the same thing? Because that would take us up to 14, potentially at the highest, but it could still be as low as 0, I guess. (10, 10, 27, 6, 6). You know, those are both coming out to the same in the end. So I'm going to have to look more at the random number generation and see how I can solve the fact that we're getting the same output given the same input numbers. which isn't really great. srand. I mean, realistically, I probably found this function on like Stack Overflow or something, and I didn't really test it that well. So what is srand in C++? Pseudo-random number generator is initialized using the argument passed as seed. For every different seed value used in a call to srand, the pseudo-random number generator can be expected to generate a different succession of results in subsequent calls to rand. Two different initializations with the same seed will generate the same succession of okay, yeah, that's kind of what I'm seeing here. In order to generate random-like numbers, srand is usually initialized to some distinctive runtime value, like the value returned by time function. Yeah, I mean, I understand that, but in my case, time is not distinct enough, apparently. Because that's the number of seconds, but I'm essentially running this within even millisecond precision. So how else can I generate something to pass in as a seed? I don't know. I'll have to research that a little bit. But for now, let's just keep those as separate inputs. So defense will be up to 15 and speed will be up to 16. And that'll be all right for our uses. Now we also have to generate our attack value based off of certain conditions here. So we get a random attack for our enemy. Well, let's just begin with the player. It's a little bit easier to comprehend. So we generate a multiplier. Now we do different things for our player versus our enemy attack. So our player attack is going to be more powerful, and our enemy attack is going to take into account a different multiplier, just to give some kind of pseudo-random variance within our attacks. But let's keep it simple for right now. So where are we at here? Reset battle and generate. Calculate damage. So float damage equals 0.0f right now. Float multiplier equals util random int cast that plus 1.0. And I'll output that to see what we're getting. And then damage equals selected attack second, and second is going to be the amount of damage there, times multiplier. Return damage. We can do other things there. We can calculate in speed and luck and whatnot, but I'm just going to keep it at that for right now. Now, one problem we have here is that that's the damage we are dealing. So attack damage, I need to put this below here. Attack damage is that. However, we need to take into account that the defender has a defense value as well. So adjusted for defense damage minus equals okay, what do we do in our take damage function? Pass in the base damage, so divided by defense time. Okay, let's just look at this. So damage minus equals damage divided by defender defense times 0.1. So actual damage is that, and we return the damage value. Put some spacing in here. Just with multiplier. Selected attack only applies in this instance to the player. I'm going to have to set a selected attack value for the enemy as well once we get to that point. So where does that happen? Show enemy, let's see. Enemy takes damage. So right here, where we are, where the enemy is attacking, so let's set selected attack of enemy. enemy dot attacks dot we're just going to take first of theirs because that'll simplify things a little bit for testing purposes. I don't think we take first. I think we just set it to first element in their attacks unordered map. So if we build this, hopefully we'll get some modicum of success in this process. Okay. So we'll pop into a battle here. Let's see. Defense 14, speed 16, luck 34. Now I'm going to attack with my axe, which is my most powerful. And I'm doing, let's see, damage 20, actual damage is minusculely small. Because their defense is quite high, maybe, I don't know. The multiplier was 1 on that. I take 1.0 or 1.667. I'm going to have to fiddle with these values a little bit because that's going to be exceedingly slow. Now, one problem is it's not resetting to the first attack here. So, damage to player. If we are showing attacks, we need to do set selected attack of enemy. Reset selected attack to first attack option of player. Again. So hopefully that makes sense. We arbitrarily selected the first attack of the enemy. They did their thing, and now we just want to reset selected attack. So once we iterate back into the start of the battle loop, my player attack menu will be reset in a way that I can actually interact with it. So I'll do minuscule damage. And yeah, it reset it how I need. That's going to be incredibly difficult here. Yeah, I'm going to have to mess with that. The multiplier is always 1. I need to figure out why that is. So what does that give me? 0 for some reason. What I really want is I'm going to have to go back and look at this random int function again because it's not random enough for my purposes. Because ultimately, what I want is for this to give me an actual integer between 1 and 9. And then we divide that by 10 to get a percentage. It's like 0.1, 0.2, 0.3, blah, 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 so on. And we add 1.0 to that, which should give us a 1.1, 1.2, 1.3, you know, etc. That may be too much to be asking for. There might be an easier way to do this. What if we do util random int (10 to 19) times, oh, how does that math work? So if we have like 14 and we multiply that by 0.1, that should be what I want. 0.1. Let's try that. So then the multiplier will be between 1.0, 1.1, all the way up to 1.9 theoretically. Yeah, 1.6, 1.9, 1.9. So why is my actual damage so incredibly small here? I think it has to do with the miscalculation that I had made when I was updating my JavaScript simulation. So defender defense times 0.1. What does that actually give us? Defense defense is 1.5. Okay. Right, so if my attack is, say, 24.0, Right here, let's see, my defense is, enemy defense is 14. Multiply that by 0.1 is 1.4. So damage, say 24 divided by 1.4 equals 17. Well, whatever the case, I'll have to mess about with these calculations. Actually, the minus equals could be our problem there. Yeah, that makes sense. So we don't want to decrement based on damage divided by that. We want to set damage to that, to the result of that calculation. That will give us probably a significantly different result here. So yeah, that's more like what I'm looking for. His attacks are very weak, so I'm not taking a lot of damage, but I'm doing more damage to him, like I would expect. And I guess once his damage gets below 0, I'm going to have to look at not rendering his health below the end of the health bar there. So to do that, where's our health bar? Display health bar. So this is the inside health percent. Health percent less than equal 25. So let's just do a simple condition. If position.w less than equal to 0, position.w equals 0. That should make it so it can't go below. I mean, you really can't have negative health, can you? Bam, 16 damage to enemy, you killed the enemy, good. It looks like this will be pretty nice, ultimately. So in the future, I'm just going to have to... I need to make it so even if I'm on the cusp of death, it's going to show just a minuscule amount of health there. So if position.w greater than or equal to, well, greater than 0, and position.w less than 1, I'll mess around with that a bit later on. I think more of what I'll do in between videos here potentially, and I'll bring you back around at the beginning of the next video, is I will keep implementing those other factors such as speed and luck, and I'd also like to have some random, like, you completely missed, type of logic. I'll get that going, and I will return in the next video with some of that baked in. So if you made it to this point in the video, I thank you very much for watching, and hopefully you will stay tuned for the next video. So thanks again.